In this lesson, we'll begin by clicking on the geometry icon and then select millimeters as the working units. In order to create our model, we'll start by sketching a rectangle on the XY plane as shown here. Next, we'll draw an arc by using the Arc by Center option. We'll now trim the bottom left corner of the sketch by using the Trim option that is contained in the Modify toolbox. And finally, we'll dimension the sketch as shown here. Now that our sketch is complete, we'll convert it into a surface by first clicking on the Modeling tab. And then, in the Concepts menu, we will select Surfaces from Sketches, and then select Sketch 1 under the XY Plane item in the Outline window. In the Details window, we'll now enter a value of 1 to define a thickness, and then click on Apply, followed by clicking on the Generate button. As we can see, the sketch is now defined as a surface model. In order to move to the simulation process, we'll click on the Project tab and then select the text Advanced Geometry Defaults in order to display the default settings. We'll next select 2D from the Analysis Type drop-down list, followed by clicking on New Simulation. Now we'll click on the Units option and make sure it is set to millimeters. Because the plate is aluminum, we'll now change the material type. Since the model will use symmetry boundary conditions, we'll first click on Model in the Outline window, and then click on Coordinate Systems. Next, we'll click on Model, followed by clicking on Symmetry in the toolbar, and then Symmetry Region. In order to invoke this symmetry condition on the vertical edge, we'll first change the selection filter to Edge. Then we'll select the vertical edge that lies on the line of symmetry, and make sure that the Symmetry Normal parameter in the Details View window is set to X-axis before clicking on Apply. We'll now repeat this process for the horizontal edge, this time making sure that the Symmetry Normal parameter is set to Y-axis. The next step is to set the analysis type, so we'll make sure that Model is selected in the Outline window, and then click on New Analysis, followed by selecting Static Structural. The load on the plate is a pressure load, which we will define by first selecting the right vertical edge, and then in the Loads menu, we'll select Pressure. The magnitude of the pressure is defined in the Details window by first changing to Components and then keying in a value of 1 for the X component. Our last step before solving is to select the values that we wish to solve for, so we'll click on Solution in the Outline window and then click on Deformation and Total, followed by selecting Stress and Normal. For the normal stress, we'll make sure that the orientation is set to X-axis in the Details window. We'll now click on the Solve button. As we can see, the maximum normal stress occurs at the top of the hole and has a value of 4.3 megapascals, which is very close to the manual calculation.